All right, Chapter 2, Review. This recording is going to talk through the Chapter 2 worksheet and how to do each problem. Like every recording that I'll make sure you utilize the pause, the fast forward button. I'm going to talk through each problem. If you don't need to hear that problem, skip it. If you need to hear it twice, review it, and so on. Just go back and watch it again and so on. So make sure you utilize this recording as you need and as you see fit. All right, get rid of it. First step, when I look at graphing question 1, I have to ask myself the question, what form is it in? And this is in standard form. When I have an equation in standard form, in order to find the vertex, I'm going to do x equals negative b over 2a. So a, b, c. So x equals negative b, which is 2, over 2 times a, which is negative 1. Negative 2 on top, negative 2 on bottom, and I divide them and I get 1. So my axis of symmetry is right down here along the x equals 1 line, and my vertex is somewhere on that line. How do I find an y value when I know an x value? I plug it in. So f of 1 equals a negative 1 squared plus 2 times 1 minus 3. Working all that out, I get negative 1 plus 2, which is 1 minus 3, which is a negative 2. My vertex is over here at 1 and negative 2. My a value is a negative 1, so my pattern is going to be the same as my basic y equals x squared, except for it's going to be upside down. So I go over 1 and down 1, back to the vertex, over 2 and down 4. 1, 2, 1, 2, 3, 4. Okay, don't go to the point, go back to the vertex. And now sketch a graph. Probably looks like this, and so on. Okay, throw arrows on the end of this because it goes forever, and answer the questions. So if x equals negative 1 was my axis of symmetry, I'll do a vertex first. X equals 1, y equals negative 2 is my vertex. Axis of symmetry, x equals 1. My maximum or minimum, this is a max. That's really the question, is it a max or a minimum, the vertex? And now my domain, remember domain for a quadratic, it's all real numbers. You can do a, r, n, I like my little paragraph r. And then my range, my y values are less than or equal to a negative 2. My largest y value, my graph comes up, 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 and it turns at negative 2. My y value's largest value is a negative 2, and it's everything below that. So y needs to be less than or equal to a negative 2. Domain, these arrows go forever. It will eventually get to all the x's. All right, there's question A. Question B, this is in intercept form. So my x-intercepts are the values for x that make each of these factors 0. And there's 3 of them. There's a factor of 2, x minus 3, and x plus 1. So this term, or this factor, has no x's. So it'll never get changed. It's just 2. This factor, what makes this 0 is when x equals 3. Because 3 minus 3 is 0. So one x-intercept is x equals 3. Another x-intercept is x equals negative 1. What makes this 0? My axis of symmetry is right in the middle, so again in this problem, it's at positive 1. Okay, so my axis of symmetry is somewhere down this line. How do I find a y when I know an x? I plug it in. So I'm going to take 1 and plug it in. One minus 3 is a negative 2. 1 plus 1 is a positive 2. Multiply those all together, and I get negative 8. So my x is 1, my y is a negative 8. Sketch my graph. This a value is a 2, so my pattern is doubled. So instead of going over 1 and up 1, I go over 1 and up 2. Instead of going over 2 and up 4, I go over 2 and up 8. And I end up right back where I should end up, which is at my x-intercepts. Got a little wide there. Okay? There's my graph. All right. Question 3. Same concept. Don't let the inequality change what you do. So normally, I'm looking at this. It's in vertex form. Normally, I have something like this in a parentheses telling me it goes left or right. This one does not have that. So it does not move left or right. When I say it, I mean the vertex, right? This is my basic parabola sitting right here. And it, meaning the parabola, moves down 5, not left or right anywhere, just simply down 5. So my new vertex is sitting down here at 0, -5. My pattern, I didn't have it on the board yet. 0, 0, when x is 1, y is 1. When x is 2, y is 4. That is my basic y equals x squared pattern. If it's 3, it's 9, and so on. This has, we are going to multiply the y values by the 3. That's my a value. That changes the y values, multiplies them by 3. So instead of going over 1 and up 1, I go over 1 and up 3. So from here, I go over 1 and up 3 in both directions. I go over 2. Normally it's 4. Now it's up 12. In both directions. And it's a super skinny parabola. All right, vertex. Oh, sorry, shading. Oh, I messed up. This is dashed line or dotted line, right? Because it's going to be just less than, not equal to. So it's not a solid line. Glad I caught that. It's just less than. Now, here's what we do. We put a pencil on the line or on the curve and ask ourselves the question, which y value is greater than, or which y value is less than that point that's on the curve? Because I'm reading this, I want all y values that are less than the curve. So this is a y value on the curve. These are less than. This is a y value on the curve. These are less than. This is a y value on the curve. These are less than. So I'm shading everything down below a curve. Okay. Vertex. Wasn't really expecting that on. This is the inequality, so we're not going to graph the vertex and all that kind of stuff for stated, but we could. Vertex is 0, -5. Axis of symmetry is x equals 0. Domain's kind of funky in range because of all the inequality stuff, so we're going to leave that out. Okay, over to here. Same idea. X equals 1, y equals 2 is my vertex. 1, 2. It is upside down. So I go over 1, down 1. Otherwise, it's the same pattern. Same pattern as this, just upside down. Over 2, down 4. Both directions. Whoops, too far. Over 2, down 4. Both directions. Solid line this time because it's equal to. Dotted line or dashed line because it's not equal to. Solid line because it is equal to. Cruise up here. Turn. And go back down. Throw arrows on the end. Forgot my arrows over here. And I want to shade below. Here's a point on the curve. This is all below. So this time, there's my shading. And this keeps going. So my shading keeps going and so on. Okay. Question 2. Write a quadratic function whose graph has a vertex. So I'm looking at vertex form. So I know it's going to be y equals a times something squared plus or minus something. Has a vertex at -5, 9. If my vertex is a -5 x coordinate, then what's inside the parentheses is +5. Don't forget the squared. That's what makes it a parabola. That's what makes it quadratic. And then plus 9's on the outside. Plug in my point to find the correct shape, the correct a value, to make it pass through the point 1, 3. So y is 3, x is 1, and solve. Subtract 9, I get a negative 6. 6 squared is 36. Divide, and a equals a negative 6 over 36, or negative 1/6. Plug it back in. Don't leave it like that. We're not done. Plug it back in. I get negative 1/6 parentheses x plus 5 squared plus 9. Question 3. Now we're in intercept form. Write a quadratic function whose graph has x-intercepts. So it's going to be y equals a. And then I have my two factors that gives me the x-intercepts. So I have x plus 5 in this parentheses, and I have x minus 9 in this parentheses. Find the right a value so that my graph passes through that point. So y is a negative 3, x is a negative 2, x is a negative 2. Working it out, I get negative 3 equals a times, this is a positive 3, this is a negative 11, so this becomes a negative 33. When I divide, I get a equals 1 over 11. Plug the 1 over 11 back in for a in my original equation, and there's my equation. Okay, so the key with 2 and 3 is just recognize, what am I given? Am I given the vertex, or am I given x-intercepts? If it's a vertex, it'll be in this form. If it's x-intercepts, it'll be in this form. Either way, my next step is to plug in the point they give me so I can find the right shape, so I can find the a value. And then just work it out, plug it back in. Okay, question 4. Function has a negative discriminant. Remember the discriminant in my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the entire quadratic formula. That is not what we want. We only want the discriminant. This part, b squared minus 4ac, that's my discriminant. Why does it matter? Because if this underneath the radical is negative, then I'm going to get an I in my answer. And I'm going to get two answers, the plus and the minus, of whatever I term this comes out to be. So if my b squared minus 4ac, my discriminant, if it's negative, I have two solutions, and they are imaginary. If this is positive, I have two solutions, and they are real. If this is 0, then plus or minus 0 doesn't do anything. It's no plus or minus because it's not subtracting anything. And so I get just one solution, but it's real. Okay, that's what it tells me algebraically, and that's what it tells me about my solutions. So think about what that tells me about the graph. If I have a negative discriminant, I have imaginary solutions, which means I have no x-intercepts. Because remember what the quadratic formula finds. It finds the value of x that makes my equation 0. The equation is what my y value represents. Y equals this equation. If this is imaginary, or, sorry, if my solution is imaginary, then this will never be 0. Okay. Write a quadratic function in standard form. All I'm doing is multiplying this out so that this looks like this. This is vertex form. This is standard form. Most of the time, we're asking you to go from standard to vertex by completing the square. This one's just a little different. Just want to see, can we FOIL? Leave the 4 alone. X minus 2 squared means take x minus 2 times another x minus 2. Multiply that out, and I get x squared, make sure we have a parenthesis, minus 2x plus 4, foiling it, still multiplying first. Whoops, that's a 1 out there. Multiply the 4 times, I'm going to combine like terms first. So inside I get x squared minus 2x is a minus 4x. Now combine like term, or sorry, now multiply. And I get y equals 4x squared minus 16x plus 16 plus 1. Final answer, y equals 4x squared minus 16x plus 17. Question 6. X-intercepts. No different than what we've been doing, just tweaked up the vocabulary on you. X-intercepts, zeros, roots, they all find basically the same thing. Some are reserved for equations, some are reserved for functions, one's talking about a graph, but the concept's the same. Find the value that makes the equation or the function 0. Okay. Question A, B, and C. Your task is to figure out what technique do you want to use. In this case, I have a single term that's being squared. I can isolate that single term. So I'm going to use what's called taking square roots. I'm just going to isolate that and solve. So pretend this is just like a variable. I'm back to algebra 1. If I had 3y minus 18 and I'm solving for y, I would simply get rid of what's being added or subtracted first. Then I would get rid of what's being multiplied, and then I could solve. So let's do the same thing. So I'm going to add 18 to both sides. I want to undo multiplication, so I'll divide by 3. I need to get to the x term. I have this squared out here that's kind of like protecting it. I have to get rid of it. So I'm going to undo the square by square rooting. And when I square root a square, I generate a plus and a minus. So the side over here becomes plus or minus square root of 6. There are no perfect squares that go into 6, so I'm simplified. I don't need to go any further. My final answer is 2 plus or minus the square root of 6 equals x. I added 2 to both sides to solve for x. And that's my answer. Question B. Stick in a 0 because I'm looking for the value of x when the function or my y value is 0. When it's in standard form, I will 99% of the time see if I can factor it first. Factors of x squared are x and x. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 6 and 4, and that's it. This is what I'm looking for. This is a negative, so I'm going to subtract these factors to see which one subtracts to 5, since that's negative. If that was positive, I'd be adding these to see if I can get 5. So which 2 will subtract to give me 5? 3 and 8. I want a positive 5, so the 8 needs to be positive and the 3 is negative. If this is negative, these signs will be different, and the larger number, the larger product, matches the sign of the middle number. Answer, x equals 3, x equals negative 8. Okay, letter C. Again, it's in standard form, so I stick a 0 out here. And I ask real quick, can I factor? And the factors of 5, there's only one set, 1 and 5. Does 1 plus 5 give me 4? No. You might say, well, 1 minus 5 does, but I don't subtract because this is positive. If this is positive, my signs are the same, and if my signs are the same, when I combine them, I will be adding to get 4. This doesn't work. If this was a negative 5, now it's factorable, but it's not. So I have to resort to something different. You can complete the square, or you could quadratic formula. I'm going to quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a, which is 1, so I don't need it, times c. Negative all over, almost forgot that, all over 2a. And a is 1, so it's all over 2. So I get negative 4 plus or minus the square root of a negative 4 over 2. The square root of negative 4 is 2i, because the square root of a negative number is I, and the square root of 4 is 2. So I get 2i. And when I divide, I get negative 2 plus or minus I. All right. Next page. Whoops. Didn't mean to do that. Number 7. Complex numbers. Biggest mistake, I think I can say biggest, most common mistake on the test or on the quiz was not recognizing that this is addition and this is multiplication. I am not going to FOIL this out. Okay? Since I have two parentheses and since this 2 is touching the parentheses, I'm going to take care of that first. So I'm going to multiply this positive 2 times 4. I'm going to distribute it. Multiply the positive 2 times the negative 5i. And now I'm simply going to combine like terms. 3 plus 8 is 11. 2 minus 10 is a negative 8i. And we're done. Be careful. Do not multiply. Don't distribute this first parenthesis to the second parenthesis. Question B. Is there a perfect square that goes into 80? What are my perfect squares? 1, 4, 9, 16, 25, 32, 49, and so on. So I would start with the biggest number possible. Does 64 go into 80? Nope. Does 49 go into 80? Nope. Does 32 go into 80? Nope. 25? Nope. 16? Yes. So I'm going to break the square root of a negative 80 into a negative 1, a 16, and a 5, because 5 times 16 is 80. Square root of negative 1 is I. Square root of 16 is 4, and 4 times 5 is 20. Square root of negative 1 is I. Square root of 5 is some decimal, so I leave it alone. Square root of 16. Why did the radical go away? Because I used it to evaluate the square root. Why did the radical not go away? Because the square root of 5 is not a nice perfect number. It's somewhere between 2 and 3, so I leave it alone. Okay, 25 is a perfect square. So then I have 3, square root of negative 1 is I, and the square root of 25 is 5. And so that becomes 15i. Okay, combine like terms. 3 minus 5 is a negative 2. 11 minus a minus 4 is 11 plus 4, which is 15i. Right, now we FOIL. So I'm going to distribute 3 times 5 is 15, and 3 times a negative 4 is a negative 12i. 11 times 5 is 55. 11 times a negative 4 is a negative 44i squared. Don't need these anymore. Okay, I squared by definition is a negative 1. So this negative 44 times a negative 1 is a positive 44. Plus 15 is 59. Positive 55 minus 12 is a positive 43i. Same idea. Since we just did it, I'm going to cruise a little bit. 4 times 2 is 8. Minus 6i. Minus 24i. Plus 18i squared. I squared is negative 1, so this becomes a negative 18. Negative 18 plus 8 is a negative 10. Negative negative is going to add those together, and I get 30 I. Okay. Number 8. Write in vertex form. First step, I'm going to get rid of that 1. So I'm going to move it to the left-hand side, move it over here. I'm going to factor out that 3. I'm going to leave myself a space. Okay, decide what I have to add. I cannot decide what to add to complete the square until the coefficient of x squared is 1. I can't do it back here. Coefficient of x squared must be 1. So I divide the 2 by 2, and I get 1, and I square it, and I get 1. So I'm going to add 1. That 1 is being multiplied by a 3, so I really added 3 to this side. When I FOIL or distribute this back out, I will get a 3 here. So I need to add 3 to this side. So I get f of x plus 2 equals 3 times x minus 1 times x minus 1, which is x minus 1 squared. Get the f of x by itself, so move that 2 back across. And I get that equation. Okay, solve by factoring. I'm going to move the move the 4 to the left and make it equal to 0. Before you can factor, before you can quadratic formula, your equation has to be set equal to 0. Okay, let's factor. Factors of 3x squared are 3x and x. Factors of 4, 1 and 4, 2 and 2. This is negative, so I'm going to subtract the product. Notice I didn't say just going to subtract these two numbers to get 1. In the past, like up here, the coefficient has just been a 1, right? So my coefficient was 1, so I asked the question, what number minus another number gives me 5, so 8 minus 3 is 5. I can't do that here. The coefficient of this one is not a 1, it's a 3. So whatever I put here gets multiplied by 3. So I'm going to put a 1 here and a 4 here. And I get 3 and 4. Is 3 minus 4 equal to 1? Yeah. So I found the right factors. I want a positive 1. So my larger product matches the middle sign. That's a positive. My larger product has to be a positive. Okay, it says solve by factoring. We have just factored. So now I have to solve it. So remember the shortcut? It's the opposite of this number divided by this number. And remember, we solved that thing. We have 3x plus 4, and the question is, when is that equal to 0? We used our algebra skills, so we subtract 4 from both sides, and that's why it's the opposite, because I do the opposite to get rid of it. And then I divide by 3, and that's why it is the opposite of this divided by this every time. Okay, this one's easy. What makes x minus 1 0 when x is 1? So these are my two answers. The factoring is not the answer. The solving by factoring, that's my answer. Okay, number 10. Find the roots by completing the square. So I'm going to move the 3x over, so I have 2x squared minus 4x, and I'm going to get rid of the 1 at the same time. So I subtracted 1 from both sides, and I subtracted 3x from both sides. Next step. Before I can complete the square, the coefficient of x squared has to be 1. It's not, it's a 2. So I'm going to divide every term by 2. Even if this came out to be a fraction that's not reducible or doesn't turn into a whole number, I would still divide by whatever's sitting here in front of the x. 2 divided by 2 is 1. And so I get x squared. 4 divided by 2 is 2. 1 divided by 2 is 1 divided by 2. Okay, add this number divided by 2 is 1, and squared is 1. So I add 1 over here. Factor. This factors into x minus 1 times another x minus 1, which is x plus 1 squared. I need to combine my like terms over here, and I get 1/2. Just looking at my answers. Okay, making sure I didn't make a mistake before I kept going. Okay, I need to square root both sides. Now we're right back to solving like we've been doing. So I square root, and I get x minus 1 equals plus or minus the square root of 1/2. Add 1, and I get x equals 1 plus or minus the square root of 1/2. Okay, and we haven't rationalized the denominator yet, which you don't even know what that means yet, so you can leave it like that. Okay, now round to the nearest hundredth, grab a calculator, type that in, and work it out. I assume you can do that. Well, yeah, I will quickly do that also. All right, so I just paused and I typed that into my calculator, and that's what I came up with. So those are your two. That's this rounded to the nearest hundredth. Okay, question 11. Solve using the quadratic formula. Before I can use the quadratic formula, this thing has to be equal to 0. So that's my first step. I'm going to add 5 to both sides. Right-hand side becomes 0, left-hand side becomes that mess. And now just walk ourselves through it. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Reducing what's underneath, I get the square root of 16. And I solve, or I use the radical, and I get 4. Negative 6 plus 4 is a negative 2, divided by 2 is x equals negative 1. Plug in, or not plug in, but do the bottom. Negative 6 minus 4 is a negative 10, divided by 2 is a negative 5. Question 12. Solve using the quadratic formula. Sounds familiar. Do the exact same thing. Set it equal to 0. Negative b, this time a negative negative is a positive 6. However, underneath the b squared is still just 36 minus 4 times a times c all over 2a, which is 2 times 7, which is 14. So on top I get 6 plus or minus the square root of negative 244. All over 14. 244 reduces down to 4 and 61. And then the negative is a negative 1. Doing some reducing, I get 6 plus or minus 2i square root of 61. And that reduces down to x equals 3 plus or minus I square root of 61 all over 7, dividing 2 out of all of these terms. When you have a fraction where there's 2 terms on top and 1 term on bottom, and you want to simplify, whatever you take out of this bottom has to come out of both the numbers on top, or both the terms on top. Okay, I think that's good. For 13, find the discriminant. So remember, it's just b squared, like I said, equals 0. So negative 3x squared plus 9x minus 4 equals 0. So my discriminant is b squared minus 4ac. B squared is 81. Minus 4a is equal to a negative 3. C is equal to a negative 4. Working this out, I get 12, 48. I get a positive 33. So there are two, there's a number, real, there's the type, solutions. Okay, solve algebraically. I'm going to set that equal to 0. And I'm going to solve this just like I would if this was an equal sign. Okay, that's how I'm going to start. So what makes this 0? I'm going to factor that. That factors into x minus 1, x minus 4. I'm going to make a little number line just to help me organize my data. And 1 is 1 0, and 4 is the other 0. And now I'm going to check. I want to know not when it's equal to 0. I want to know when it's greater than 0, meaning when is it positive or 0. Okay, so I know I have one answer, is 1 and 4. But I have more. There's more places where this product is positive. So I got to find them. So to do that, I'll put my zeros here and check each region to see what's the sign when I plug in the x value into the equation. What is the sign? Is it positive or negative? So I'm going to pick something down here like 0. 0 is less than 1. 0 is over here. 0 minus 1 is a negative 1. 0 minus 4 is a negative 4. And a negative times a negative is a positive. No matter what x value I plug into my function that's below 1, my answer, my equation, will work out to be a positive number. Something between 1 and 4, like 2. Plugging in 2 makes this number a 1, makes this number a negative 2, and a positive times a negative is a negative. Plug in something bigger than 4, like 5. 5 minus 1 is positive. 5 minus 4 is positive, and a positive times a positive is a positive. So there's my little number line. Now I got to answer the question. Solve the following. Where is x squared, etc., greater than 0? Where is this positive? Well, when my x's are between a negative infinity and 1, and between 4 and positive infinity. Not including 4 because it's 0 there. Oh, sorry, I am including that. See the inequality sign here? I'm glad I caught that. That inequality sign there means I do include the 4 and the 1. So I got to change that to a bracket so that I include the 4 and the 1. I knew that. I was just testing you guys. Glad I caught it before I went on. All right, so do we see that? Since that is an equal to, it is greater than or equal to, I want to know where is it positive or 0. And it's 0 at 1 and 4, and it's positive out here. I can't include the infinity, so I won't have a bracket on the infinity. It'll just be a parenthesis. Now, let's show that we're going to put these two sets together. There's my fancy math symbol. It's called a union. I'm going to union, or I'm going to put together every element in this set and every element in that set. Okay? It is not an and. X doesn't have to be in this this set and this set at the same time. That's what an and means. This means or. It needs to be in this set, or it needs to be in this set, and both of those would be true. If it was in either one of those, it'd be true. Okay, solve. Set it equal to 0. Well, sorry, can't draw. Okay, so moving the 3 across. That's a negative x squared minus 2x minus 3. No, plus 3. Okay, let's factor that thing. So I have 0. I have a negative. Let's get rid of that negative sign. Okay, because a lot of times we don't factor with a negative sign there, so I'm just going to get rid of it. When I divide by a negative, I flip the inequality sign. So I'm going to divide everything in this set and everything over here by -1. Negative flips. 0 divided by -1 is just 0. Negative divided by negative is a positive. Negative divided by negative is a positive. Positive becomes a negative. That looks more like what we're used to. I'm going to factor that. We could have factored the other way. It just makes it easier to read and easier to solve when the x squared is positive. Factors of 3 that will subtract to give me 2. Why am I subtracting? Because that says to. This tells me whether I add or subtract my factors. As long as this is positive. If this is negative, it kind of tweaks those rules a little bit. So what factors of 3 will subtract to give me 2? Pretty easy, 1 and 3. I want a positive 2, so the 3 is positive and the 1 is negative. Go to number line. X equals -3, x equals +1. So try numbers, make sure they're in order. Okay, the -3 is smaller than 1, so the -3 is on the left and the 1 is on the right. Okay, try numbers less than -3, like a -4. -4 makes that negative, -4 makes that negative. I don't care about the number, but let me just show you the number. -4 minus 1 is a -5, but again, I don't care about the 5. -4 plus 3 is a -1, but I don't care about the 1. -5 times a -1 is a positive number. It's a positive 5. Okay, try something in between, like 0. Plugging in 0 gives me 0 minus 1 is a negative number. 0 plus 3 is a positive number, and a negative times a positive is a negative. Last one, put in something bigger than 1, like 2. 2 minus 1 is positive, 2 plus 3 is positive, and positive times a positive is a positive. I want the expression, the x squared, etc., to be less than 0. I want to plug in an x value and get a negative answer. Where does that happen? When my x's are between -3 and 1. I include the -3 because it says or equal to, and I include the 1 because it says or equal to. If you like inequality notation, you can do this also. X needs to be satisfying this inequality and this one at the same time. Oh, I could have gone over here. This you could also write as x is less than or equal to 1, or x is greater than or equal to 4. So you could write this in inequality notation also. Interval notation, inequality notation. Don't care which one you use, but by the end of the year we should be able to do both, and we should be comfortable with both. In pre-calc next year, you are going to see both. All right. Question 16. Let me see how long this thing is. All right, we can do 16. Question 16, write an equation. We've talked about this, so let me just give you the generic equation for a height versus time question. So some height after some point in time is equal to a -16t squared plus the initial velocity, v sub 0, times time, plus the initial height, h sub 0. So now I just plug in the values. Write an equation that models the height. So it's going to be h of t, -16 stays -16 t squared, initial velocity, thrown with an initial velocity of 38. So my initial velocity, my v sub 0, is 38. From 16 feet above the ground, my initial height is 16. There's question A. Question B, how long before it hits the ground? Height when it hits the ground is 0. So I plug in 0 for h, and I solve. Notice It's simply a quadratic equation set equal to 0. There's no difference between this word problem and what we've been doing for the whole worksheet. Solve that thing. Pick a technique. Quadratic formula, factoring, complete the square. Don't care as long as you can do it. I'm going to do quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And a is 16, so it's a negative 32. So there's my x equals. Grab a calculator, type that mess in. And when I do that, I get two answers. One of them is 2.74 seconds, and one of them is a negative number. The negative number doesn't make sense, so my answer is how long before it hits the ground? Not x, I guess, but time equals 2.74 seconds. Okay, what is the max height of the ball? This is in standard form. So I'm going to go x equals negative b over 2a. Nope. 2a. And I get negative 38 divided by negative 32, and I get, I actually didn't do that. Let me grab a calculator. When I do that, I get 1.18785 seconds. That's when the max height is. What is the max height? It's not when. What is the max height? I plug that into my t. I plug it into t, and I work it out. So the maximum height I come up with is 38.6 feet. Okay, max height 38.6 feet. Question D, when will the ball be 45 feet above the ground? Never. Max height 38.6 feet. When will it be 45 feet? It won't. Had you not seen that and you plugged the 45 into here, right, for height, and moved it over here, set it equals 0, and did quadratic formula, your discriminant would have been negative, which means it never hits it. It's an imaginary x-axis. Okay. Oh, I copied it twice. Let's keep going, just a little bit more. Question 17. Here's my, again, height versus time. I just gave it to you this time. So the geyser sends a blast of boiling water into the air. The initial velocity is 70 feet per second. From a height of 0, it shot from the ground. What's the initial velocity? Oh, I just told you. 70 feet per second. How did I know that? Just looked at my form. Right? Remember back here? My h of t equation. The number, the coefficient touching the t value is my initial velocity. The coefficient, where'd it go? The coefficient touching the t value, or the t variable, is my initial velocity. Max height. It is in standard form, so x equals negative b over 2a tells me that. So I get negative 70 over negative 32. And x comes out to be 2.1875. That's when. Now I want, what is the max height? I take that 2.1875, I plug it back in for t, into both of these t's, and I get an h value, give me a second, of 76.56. feet. Vertex is where my max height occurs. To find the vertex in standard form, I do negative b over 2a to find the x-coordinate, plug it back in to find the y-coordinate. Okay, how long is the boiling water in the air? Well, it was released at time equals 0. The max height's at 2.1875, so we could technically just double that, but let's just show that it works out by putting in 0. for height, because that's when it hits the ground, right? When the height above the ground is 0. So I put 0 in there. And I'm going to solve that. So I'm going to subtract or add 16t squared. No, I'm not. I'm going to factor. That's a more proper way of doing it. I'm going to factor out a negative 16t. And I get t minus 4.375. So I factored out a t, and I went ahead and factored out the 16, but I did not need to, but I just did. So now I can see when t equals 0, the water is on the ground, and when t equals 4.375, the water is on the ground. How long was the water in the air? This 4.375 minus 0, which is 4.375. Had we simply doubled this number, right, the time it takes to get up and the time it takes to go back down, you would have also got 4.375. That is t, and that is seconds. Okay, get rid of this guy. Number 18. Using the graph of the parent function, y equals x squared, as a guide, describe the transformations. So let's do each one of them. The negative, reflection, over x axis, spelled correctly. The 1/3, a vertical shrink. The plus 2 is left 2, and the minus 4 is down 4. All right, that was simple. Question 19. Using the same equation we've been using, h of t equals negative 16t squared, initial velocity 256, from a pit that is 160 feet below the surface. So we're going minus 160. How long does it take for the object to reach its max height? Max height, x equals negative b over 2a. Negative 256 over 2 times that, which is negative 32. And my answer comes out to be 8. How long does it take to reach max height? 8 seconds. What is its max height? You plug in 8 into the formula for t, and you solve. Grab a calculator, type that mess in, and I come up with somewhere 864 feet. When will the object reach the ground level? Put in 0. And you can pick quadratic formula, complete the square, and by now you know what I'm picking. I'm picking quadratic formula, and I get time equals 0.65, and time equals 15.35. Does it make sense for this object to be at ground level? Let's just say this is a negative 160, and the object is being thrown up, and it comes back down. Does it make sense for there to be 2 times when it's at ground level? Yes. Once on the way up, 0.65, and once on the way back down, 15.35. Okay, glad that made sense. Get rid of this. Now the question is, when is it 25 feet above the ground? Not 0, so I put 25 here. And I do the exact same thing. In order to use quadratic formula, I have to have it equal to 0. It's not, it's 25. So I'm going to subtract 25 from both sides. I get negative 185. All that stays the same because I'm just subtracting from the constant. I dump that mess into quadratic formula. There's my A, there's my B, there's my C, and I get t equals 0.76, and I get t equals 15.24. No. Yeah. Does it make sense that it's longer on the way up but shorter on the way back down? Yeah, because remember our picture is at negative 160 down here. 25 is up here now, so the time is just a little bit longer than what it took to get to the ground level, right? Because it goes a little bit past ground level. But then on the way back down, it gets to 25 before it gets to ground level. So this number is bigger than this one, but this number is less than that one. That makes sense. Okay, sketch a graph. Placing all of the key points on my graph. Let's actually make one that is kind of straight. Sorry, got a cough. All right, so I'm going to count by, I don't know, hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down below 1, 2. So there's negative 200. So negative 160 is sitting like right here. And after 8 seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After 8 seconds, 2, 4, 6, 8. 2, 4, 6, 8. After 8 seconds, it is at the highest point of 864. So like right here. 1, 2, 4, 6, 8. There's 800. There's 200, and so on. So then at, what was it, 0.75 and so on, and at 15 point something, it was here, and so my parabola goes up, reaches max height, turns, whoa, where's I going? Turns, didn't turn fast enough, turns, and goes back down. And it hits 160 back down here after 16 seconds. How do I know that? Because it's symmetric, right? This is my axis of symmetry, and this point reflects straight across to here, so this is 16 seconds. Okay. I think we got just a couple more. Yeah, I'll go ahead. All right, so this recording is pushing an hour, so I'm going to try to speed things up a little bit. So if we're looking at this here, question says sketch the graph of a quadratic function where the leading coefficient is negative. Think about what that means. Negative leading coefficient means my graph will never cross the x-axis. And the discriminant is negative means my graph will never cross the x-axis. Negative leading coefficient means my graph is upside down. So I need to graph a function that is upside down that doesn't cross the x-axis. There's an infinite number of options, just anything. Looks like a quadratic, upside down, not crossing the x-axis. Discriminant negative, doesn't cross the x-axis. Negative coefficient, upside down. Okay, question B. Leading coefficient is positive, so now let's write that up. And the discriminant is positive. Remember, a positive discriminant means it crosses the x-axis twice. So we have anything like that. Right side up, crossing the x-axis twice. Okay, last one. Discriminant is positive, crosses the x-axis twice. And the vertex is in the third quadrant. There's quadrant 1. There's quadrant 2. There's quadrant 3. Put the vertex over here. Same as question B. Positive discriminant means it crosses the x-axis twice. Anything like that. Right. Question 21. We have an equation that describes the cost of a function based upon x, the number of units sold. Sorry, number of units produced. So the question is, how many fixtures should be produced to minimize the cost? Remember, my vertex is where my minimum occurs. Okay, so this question is essentially asking, what is my vertex? So how do you find the vertex in standard form? X equals negative b over 2a. B is 10, sorry, b is negative 10, so the top is 10. A is 0.25, and so my x equals 10 divided by 0.5, or x equals 20. How many fixtures should be produced to minimize the cost? 20 fixtures. Now, if the question asked how many or how much would that cost be, you'd take that 20, plug it back in for the cost equation, and figure out the cost. Okay, 22. Let's draw a picture. So we decided to plant a garden. It's a rectangular garden, and the length is 3 feet longer than its width. So I'm going to call this the length. I'll call this the width, and my length is 3 feet more than the width. So W plus 3. The area is 88. So we're going to multiply length times width back from geometry to get area. Distribute that W, and I get 3W, or sorry, I get W squared plus 3W. It's a quadratic, so we're going to set it equal to 0. We're going to subtract that 88 from both sides. And I usually try to factor first before I jump right into the quadratic formula. So factors of 88 are 11 and 8, and they do subtract to give me the 3. So I have a plus 11 and a minus 8. So my width is 8 feet, and my length, not 88 feet, sorry. My width is 8 feet, and my length, remember the length was W plus 3, so my width is 8, so my length is 11, W plus 3. And we're done. Okay, question 23, solve by graphing. So I'm going to graph this, and I'm going to find out where it equals 3. So the first step is to graph this as if this said y equals. Vertex at 5, 7. So my vertex here at 5, 7. My graph is upside down, so I go over 1, down 1, over 2, down 4, and so on. Where does this graph equals 3? Right there, and right there, at x equals 3, and at x equals 7. Why? Because that is where on the graph, that's the x values on the graph, where y is equal to 3. Pretend that 3 is a y, graph it, and then find out where it crosses 3. You could also draw a horizontal line cruising across here at 3, and find out where they intersect. Okay. Last one, question 24. Use your calculator to solve the following equation graphically. So in y1, I'm going to type in 5, and in y2, we're going to type in 2x squared minus 5x minus 1. So in y1, we're going to type in 5, and in y2, we're going to type in 2x squared minus 5x minus 1. Goes up here to graph. Before I do graph, I'm just going to go zoom 6. Remember 6, zoom standard? It just fixes my window from a negative 10 to 10, and that's just a good place to start. When I know my numbers aren't really big. My numbers are nice and decent, so I think that the negative 10 to 10 is a good place to start, and it is. So I can see everything I need to see. This is what I'm looking for, where my two lines intersect, where my curve is equal to 5. Just like we did by hand, but this time it's on a graph. And it needs to be on a calculator because it's not an exact value. So I go here, second, and trace, which is my calculation. These are all the things my calculator will calculate from a graph. What do I want? Number 5. I want the intersection. So I cruise down here to 5, and I hit enter. Or I could type the number 5. Now it's going to ask me a couple questions. It's not asking me the questions. Let me get out of here, because that's not right. Go back to graph. So I'm going to go calculate number 5. There we go. That's the question I was looking for. First curve. Is this y1 the first curve? Yes. Hit enter. Is this y2? See the question? Second curve? Question mark. Is this y2 the second curve? Yes. Hit enter. Make a guess. Why do I need to make a guess? So that the calculator knows which one you want it to find, and it uses your guess in the algorithm to find the solution. Just get it close. The closer you get it, the faster you'll get the solution, but it's really not that big a deal. Just get it close. So my answer is negative 0.886. So there's one answer. X equals negative 0.886. So I go over here, I write that down. X equals negative 0.886. Go back and do the other one. Same procedure. Second, trace, which is calculate. Number 5. So I can just push the number 5. First curve, is the y1 the first curve? Yep. Is the y2 the second curve? Yep. Make a guess. Now I don't want that to be my guess. Now I'm going to cruise over here. And I could also type the number. Looks like about 3.5. So I could also just type in 3.5 as my guess. And that's close. 3.38 or 3.39. So those are my two answers. All right. Hope that helps. I will be around on Monday if you have questions before our Tuesday test. Hope this helped. If you have questions, come see me.